Hello, my name is Jason Cannon, and in this video, you're going to get a crash course in Linux system administration. My goal is to expose you to as much information as possible in the relatively short time we have here together. Because there's nothing worse than not knowing where to start, I created this video to point you in the right direction. I may not go into great detail, there just isn't enough time to cover every topic in depth, but when you need to perform a Linux admin task, you'll at least know where to start. Be sure to download the slides by clicking the link below the video. I packed these slides full of concepts and commands that you'll want to be familiar with, and you can refer back to them whenever you need to. So, who is this video for? Quite simply, it's for anyone who is at all interested in developing Linux system administration skills. If you're new to IT or thinking about pursuing a career in IT, this will give you an idea of what's involved in becoming a professional Linux system administrator. This video is also great for IT professionals with experience on other operating systems and who are considering adding Linux skills to their resume. Finally, this video can be used by those who have Linux experience but want to increase their existing knowledge or even quickly brush up on their skills. Why am I here teaching you about Linux? Well, let me tell you. I dropped out of college to follow my childhood dream, which was to be a full-time musician. I played in bars, restaurants, and hotels. I played music at weddings, at music festivals, and at private parties. I even spent a couple of years playing music on a cruise ship. I worked my butt off in the music business, and because I didn't make much money from the music business, I had to get a day job. My parents told me to get a safe, secure job. Did your parents ever tell you that? Well, I hate to admit it, but they were right, so I was looking for job security around this time. Not only did I want job security, I wanted a decent salary after spending many years as a starving artist. That's why I decided to pursue a career in IT. I created a resume and sent it out to everywhere I could think of. I applied to job after job until somebody finally gave me an opportunity to work as a desk side support technician. I was only in the desk side support position for just a few months because I decided I wanted to learn an in-demand skill so I wouldn't have to worry about finding a job again. I saw there were tons of jobs available for people with Linux skills, so I went about learning everything I could about Linux. Soon afterwards, I landed a job as a Linux system administrator, and as they say, the rest is history. Because Linux has given me so much in my life, places to live, food to eat, vacations, practically everything, I feel that I need to pay it forward. Teaching people Linux skills is my way of giving back, and that's why we're here today. Here are a couple of students of mine that have taken one of my courses. Chris says that it's an excellent course on Linux. It's the best way to get started using Linux that I've come across. Another student says that it's absolutely one of the best courses I've taken. Finally, John says that it's a fantastic course and very beautifully explained. Comments like these keep me motivated and make me want to teach even more. Okay, let's get right to it and start talking about the Linux boot process. BIOS stands for Basic Input-Output System. It's a special type of firmware used in the booting process, and it's the first piece of software that is run when a computer is powered on. The BIOS is operating system independent. Its primary purpose is to test the underlying hardware components and to load a bootloader or operating system. There are two primary Linux bootloaders. The first one is Lilo, which stands for Linux Loader. The next one is Grub, which stands for Grand Unified Bootloader. Grub has replaced Lilo at this point, but you may run into some old Linux systems that still use Lilo. The primary purpose of the bootloader is to start the operating system. It typically does this by using an init-rd, which stands for Initial RAM Disk. The init-rd is a temporary file system that's loaded into memory when the system boots. This file system can contain helpers that perform hardware detection and load the necessary modules to get the actual file system mounted. Once the init-rd mounts the actual root file system, its job is done, and the operating system continues loading from the real root file system. The Linux kernel, the initial RAM disk, and other files needed to boot the operating system are stored in /boot. The Linux kernel is typically named VM Linux or VM Linux. If the kernel is compressed, it is named in the VM Linux format. When a Linux system boots up, there can be a lot of messages that just fly by the screen. These messages are generated by the Linux kernel. There are two ways to see these messages. The first way is to use the dmesg command, dmesg, which dumps the contents of the kernel ring buffer to the screen. Since the messages are stored in memory in a ring buffer, when new messages get added to the buffer, old messages get dropped off. The good news is that the kernel messages are typically stored on disk in the var log dmesg file. Linux uses run levels to determine what processes and services to start. Each distribution can be configured differently, but in general, run level 0 is used to power off a system, run level 1 is single user mode, run levels 2 through 5 are for normal system operations, and run level 6 is used to reboot a system. Traditionally, run levels were controlled by the init program. To change run levels, you would use the tell init command to literally tell init what run level to use. However, init alternatives such as systemd and upstart are quickly taking the place of init, with systemd currently being the most widely adopted replacement. Instead of run levels, systemd has the concept of targets. These targets are roughly equivalent to run levels. You can use the systemctl command to change to the desired target. In addition to run levels and targets, there are some special commands that allow you to control the system. For example, you can use the shutdown command to shut down the system, the reboot command to perform a reboot, and the power off command to power off the system. Linux uses the syslog standard for message logging. This allows programs and applications to generate messages that can be captured, processed, and stored by the system logger. It eliminates the need for each and every application having to implement a logging mechanism. It also means that logging can be configured and controlled in a central location. The syslog standard uses facilities and severities to categorize messages. Facilities are used to indicate what type of program or what part of the system the message originated from. For example, messages that are labeled with a kern facility originate from the Linux kernel. Severities are used to categorize messages based on their urgency. The severities are emergency, alert, critical, error, warning, notice, and info. A syslog server accepts syslog messages and processes those messages based on a set of configurable rules. Traditionally, the syslog-d daemon filled this role, but many Linux distributions ship with alternatives such as rsyslog and syslog-ng. A syslog server will use configurable logging rules to determine what to do with a message. These rules use combinations of facilities and severities. In most cases, messages are simply written to a file in var log somewhere, but you can do advanced things such as send the messages over the network to a central location. If you want to generate your own log messages, use the logger utility. To automatically prune log files and keep your disk from filling up with old messages, use the log rotate utility. When a disk or storage device is partitioned, it is divided into parts. Each one of these parts is called a partition. Partitioning a disk allows you to allocate different sections of the disk for different purposes. There are two types of partition tables. One is the MBR partition table. MBR, which stands for Master Boot Record, is an older technology that can only address up to 2 terabytes of storage space. It is being replaced by GPT, which stands for GUID partition table. GUID stands for Global Unique Identifier. GPT supports up to 128 partitions and supports storage devices up to 9.4 zettabytes. A mount point is simply a directory that is used to access the data on a partition. At the very least, there will be one partition mounted on the /mount point. Any additional partitions will be mounted on mount points below / in the directory tree. For example, if you allocated a partition for user home directories, that partition would be mounted at /home. The files and directories that are at or below the /home mount point will reside on that partition. For example, the files in my home directory /home/json will be on the partition that is mounted at /home. When performing interactive Linux installations, you will most likely end up using a partitioning tool provided by the Linux distribution. However, if you want to manipulate disks after the initial installation, you'll most likely need to use a standard Linux tool. The fdisk utility has been traditionally used to create and modify partitions on a disk, but there are other viable alternatives including gdisk and parted. Before a partition can be used by a Linux system, it will need a file system. You can use the mkfs command to create file systems. Simply supply the file system type to the -t option and then provide a path to the device for the partition. Once you have a file system created, you can mount that file system using the mount command. To show how much disk space is in use the df command, which you can think of as the disk free command. If you want to disconnect a file system from the Linux server, use the umount command. That's unmount without an N. Supply the mount point or device to umount to unmount the device. In order to control what file systems get mounted where and in what order, use the etc fstab file. fstab is short for File System Table. You can use device paths, labels, or UUIDs to control mount points. A UUID is a universally unique identifier. To view the labels and UUIDs of the storage devices attached to your system, use the lsblk-f command. If you're only interested in the UUIDs, you can use the blkid command. Each file system type will have a utility to create disk labels. For extended file systems, which is one of the most commonly used Linux file systems, you can use the e2label command to set the label of a disk. Each account consists of a username, a unique number called the UID, short for user ID. Also, each account has a default group to which it belongs, some comments associated with the account, a shell to execute when the user logs into the system, and a home directory. All of this information is stored in the etc password file, and that's spelled PASSWD. Historically, encrypted password information was also stored in etc password. However, the etc password file is readable by anyone on the system, so storing password information, even if it's encrypted, is a security risk. Now, by default, the encrypted password information is stored in etc shadow, which is readable only by the superuser account. If you want to create an account, use the user add command. Delete accounts with userdel, and modify existing accounts with the user mod command. These are low-level Linux commands and are available on all Linux distributions. However, some distros provide their own account creation tools that you can use if you so choose. Just like the etc password file contains account information, the etc group file contains group information. To create a group, use the group add command. The group del command will delete a group. To modify a group, use the group mod command. To see what groups an account is in, use the groups command. If you want to switch to another account, use the su command. To verify which account you are currently using, run the whoami command and it will return the account name. The sudo command is used to allow one user to run commands as another user. This is most commonly used to allow a normal user to execute a program as the superuser. You can think of sudo as superuser_do. To start a shell as another user, run sudo -s. You can also run sudo -su. To modify the sudoers file, use the vi sudo command. It has syntax checking built in, so you won't inadvertently break sudo. The TCP/IP protocol is the de facto standard for transmitting data over a network. TCP/IP stands for Transmission Control Protocol and Internet Protocol. For a device to communicate on a network properly, it needs three pieces of information. First is an IP address, then a subnet mask, and finally a broadcast address. Each one of these numbers is comprised of 4 octets separated by a dot. An octet represents 8 bits and therefore can have a value starting at 0 and going up to 255. The class of an address determines what portion is used as the network address and what portion is used for the host address. By looking at the first octet of an IP address, you can tell what class it is. An IP address with a first octet that falls between 1 and 127 is a Class A IP address. Class B addresses begin with 128.0 and end at 191.255. Class C addresses start with 192.0.0 and end with 233.255.255. A class determines the possible number of networks and the addressable space per network. For example, a Class A network can accommodate about 16 million host addresses, whereas a Class C network can only address 255 hosts. The subnet mask splits an IP address into two parts. The first part is the network address or network ID. The second part is the host address. The network portion of an IP address corresponds to the 255s in the subnet mask. For a standard Class A network, the subnet mask is 255.0.0.0, since the first octet is used to identify networks, and the remaining three octets are used to address hosts. CIDR stands for Classless Interdomain Routing. It allows networks to be subdivided regardless of their traditional class by explicitly assigning subnet masks. These subdivided networks are called subnets. Also, there are ranges of IP addresses that are dedicated for use in private networks. These private addresses are also called non-routable IPs since they are not routed through the public internet. To show your current IP address or get a list of all the IP addresses in use on your system, you can run IP space address or ifconfig. At this point, the ifconfig utility is considered to be deprecated, but you can still find it installed by default on many Linux distributions. A host is a device connected to a network. Since we're talking about TCP/IP networking, a host in this case is a device with an IP address. A host name is simply a human-readable name that corresponds to an IP address. You can run the hostname command to display the hostname of a system. You can also run uname space -n. If you want to display the FQDN or fully qualified domain name, run hostname space -f. The primary purpose of DNS, which stands for Domain Name System, is to translate human-readable names into IP addresses. Of course, DNS does the reverse as well. It can translate an IP address to a host name. If you want to look up or resolve a DNS name or an IP address, you can use the host or dig tools. In their most simplest forms, you specify the IP address or DNS name that you want to look up as an argument to the command. The etc host file contains a list of IP addresses and host names. After you created an entry in etc hosts, you can start communicating with that IP address by using the name you specified in the host file. This can be useful if you want to access computers that do not have DNS host names. Also, it's common to use etc host entries to override the DNS entry of a system. For example, if you have a cluster of web servers, you could have a private network that only the web cluster members can access. You can create an entry for the members of the cluster in etc hosts and use their private addresses, thus forcing network communications through the private network. Typically, the etc host file is checked first before a DNS server is queried, but you can change this behavior by editing the etc nsswitch.conf file. NSS stands for Name Service Switch, and it controls the order in which lookups are performed. Just like IP addresses identify hosts on a network, ports identify the services on a host. When a service starts on a system, it binds itself to a port and listens for traffic destined for its port. Ports range from 1 to 65,535. Ports 1 through 1023 are called well-known ports or system ports. These ports are pre-assigned ports and are used for common system services. These ports are also called privilege ports since it requires super user privileges to open these ports. Ports above 1024 can be opened by any normal user on a system and are called unprivileged ports. DHCP stands for Dynamic Host Configuration Protocol. DHCP is primarily used to assign IP addresses to hosts on a network. You must define if you want the network interfaces on your system to use DHCP or static addresses. For Red Hat-based systems, this configuration is stored in the etc sysconfig network-scripts directory. There is a configuration file for each network interface on the system. For Debian-based distros like Ubuntu, the network configuration is stored in the etc network interfaces file. You can manually assign IP addresses to network interfaces using the IP or ifconfig commands. However, many Linux distributions include ifup and ifdown scripts that can be used to easily bring up or down a network interface. A GUI is a graphical user interface, and TUI stands for textual user interface. Some distros come with GUI or TUI tools that you can use to configure the network settings on a Linux server instead of editing the configuration files by hand. These tools include NMTUI and system-config-network for Red Hat-based systems and YAST for SUSE systems. At this time, there are no official Ubuntu or Debian GUI or TUI tools to do network configuration. To query the process table and see what processes are currently running on a system, use the ps command. If you want to stop the execution of a command that you entered in on the command line, type Control-C. If you want to suspend the currently running foreground process, type Control-Z. To send that suspended process to the background, run BG. To bring that job back to the foreground, type FG. To display a list of jobs, use the Jobs command. If you want to kill a process or a job, use the kill command and supply the process ID or job ID. If you need to repeat a task on a schedule, you can use the Cron service. The Cron service is a time-based job scheduling service that starts when the system boots. Cron jobs are often used to automate a process or perform routine system maintenance, such as rotating log files. You can schedule cron jobs by using the cron tab command. Packages are used to install software on Linux systems. You can manipulate packages with a package manager. Two of the most popular package formats are RPM and Debian. For RPM-based distributions like Red Hat, use the yum and RPM commands to manage packages. For Debian-based distributions like Ubuntu, use apt and dpkg. I know I covered a lot of material in a very short period of time in this video. I just wanted to at least expose you to some of the common aspects of Linux system administration. This video really only scratches the surface, so if you'd like to dig deeper into any of these subjects and others, then you should enroll in my Linux system administration course. I go into great depth on several topics, including how the boot process works on a Linux server and what you can do to control it, the various types of messages generated by a Linux system, where they're stored, and how to automatically prevent them from filling up your disks. Disk management, partitioning, and file system creation. Managing Linux users and groups. Networking concepts that apply to system administration and specifically how to configure Linux network interfaces. Go into great detail about process and job management and how to configure sudo. Also, I touch on Linux shell scripting. We cover file and directory permissions also, and much more. All in all, that's hours and hours worth of content spread over dozens of high-definition videos that not only teach you the concepts, but also demonstrate how to do the actual work on real live Linux systems. You'll be able to look over my shoulder as I log into a Linux system and share with you the most helpful commands and demonstrate things that can only be understood once you see someone do it. So why should you enroll now? First off, you'll get access to a live question and answer session that I'll be doing for the people that enroll now. I'll give you a couple of weeks to go over the course content. Then you can ask me questions directly on a conference call and screen sharing session. If you can't make it, don't worry. You can submit your questions ahead of time and I'll be glad to answer them and send you the recording. Secondly, I want to add even more content to the course and I'll send out a survey to those that enroll now. I'll be taking the most popular topics, creating lessons on those topics, and adding them to the course. You get to decide what's in the course. How cool is that? Next, I'll be creating a course dedicated to shell scripting, and I want to help people one-on-one with their shell scripts. I'll be asking for volunteers from those of you who enroll using the link I'm about to show you. You'll be able to schedule a time with me where it'll be just you and me on a screen share session. We'll write scripts together, and I'll be happy to help you with any script that you're working on. In addition to all this, I'm also going to be offering this course at a ridiculously low introductory price. Linux system administration courses easily sell for $2,000 to $2,500 a piece. Because I want to reward those that have been waiting patiently for this new course, I'm offering this course at a super low introductory price. Nope, it won't cost you $2,500 or $1,500 or even $500. This week only, it's just $99. To enroll now, visit linuxmastery.com. I'll be raising the price to at least $297, if not more, next week. And that's without access to the live session and shell scripting help. To get started now, visit linuxmastery.com. That's linuxmastery.com. That website will redirect you to where I'm hosting the course, and it includes an embedded coupon code that gives you access to the special introductory price. If you have any questions about the course, just let me know. Otherwise, visit linuxmastery.com and get started today for just $99. I'll see you on the inside. Thanks.